Siapa ni? Chun Kiat. Okay, Chun Kiat. How are you?
Yes, I'm fine.
Okay, so last class apa yang kita belajar on project management?
Not hafal.
Dah lupa
Sorry.
Stres ke? Kerana nak ada quiz tadi?
No, because our test is nearing. So even
Okay. So apa belajar last week on project management? Still remember?
no.
Forgot already Okay, Jonathan. Okay, Jonathan. Can you share with us what we learned last week?
Doktor, saya pun tak ingat, doktor.
Wah, kenapa Kenapa tak ingat Kenapa tak ingat?
Saya rasa alasan sama je kot, sir. Sebab kita orang tengah prepare ni untuk exam. So, last week pun masa busy sikit. So, I tak boleh berapa ingat, sir.
Exam ada berapa exam this week?
Minggu ni kira 3, doktor, bagi kita orang selang 1 hari.
Wow. So next week ada berapa exam?
Next week 2.
Next week 2.
2. IE dengan apa?
Heat transfer.
Different day kan?
Tak ada gap, tapi tak ada gap.
Tak ada gap?
Yes, doktor.
Maksudnya apa? Maknanya continue one day. Different day.
Yeah.
On the first have heat transfer, second have industrial engineering.
Industrial engineering is I think on second. Second hari apa tu? Sunday kan?
Yes, sir.
So you have test on Saturday?
Yes, sir.
Oh, okay. Okay, Shafiq. Can you share with us what we learned last week?
We learn about activity on node and activity on arrow, where for the activity on node, we determine how to calculate the earliest start, earliest finish, and latest start and latest finish.
Okay.
Where for the earlier finish, we add on the earliest start and duration.
Okay. Alright.
While for the latest start, we the latest finish is minus by duration.
Okay. So why we do this? Why we do this calculation? Early start, early finish, late start, late finish, and we do forward pass, right? Remember forward pass? Okay. So for doing forward pass, we can know that what is the early finish for the activity. When we do backward pass, we will know, okay, the late start and late finish. Okay, late finish and late start. So why we need to do all this calculation? What we want to do at the end of this calculation?
So we will get shorter period of time to
Okay,
finish the project.
Yes, we will know when is the shortest period of time to complete a project. Okay, remember in the example that we discussed, we have 25 weeks, right? To complete that project. When we do critical pass, finally we get how many weeks? Based on the example we discussed?
15 weeks.
Only 15 weeks. Okay, only 15 weeks instead of 25 weeks. So critical path giving us the shortest time to complete a project. Okay, the shortest time. Maknanya masa paling pendek. Can we go shorter than that? Boleh tak? It's not possible. Not possible to go shorter than that. Unless we do what we call it crashing. Crashing maknanya kita pendekkan masa, but it will incur additional cost. Okay, ada cost tambahan. Okay, ada cost tambahan kalau kita nak pendek lagi daripada 15 minggu. Okay, we also learn about need to know about the slack. Slack. Okay, you can switch off your camera now. Okay, let me move on with the calculation of this project network. Okay, I would like to share the textbook. Okay, I've also shared with you the PowerPoint. Okay, I share with you the PowerPoint. Okay. Okay, I'm sharing now the. Okay, do you see the textbook on your screen now? Hello.
Yes,
Yes.
Doctor.
All right. Okay.
Tak nampak, Doktor.
Tak nampak.
Keluar kelabu-kelabu je.
Labu ya. Sekarang tak nampak.
Tak, dia tak nampak.
Saya stop sharing dulu. Okay, stop sharing. Okay, saya cuba share semula. Oh, bukannya ini nak share. Okay. Okay, sekarang nampak apa? Nampak tak textbook, e-book,
Black screen, sir.
black screen?
Blank.
What is the problem? Okay, sekarang nampak ya?
Yes, sir.
Alright, so this is your e-book. Let me go through this. Let me go through this example here. Okay, I just go through this example. Okay, let's say you are given this activity A, B, C, and E. Okay, and immediate predecessor. Okay, immediate predecessor. And we see that here. Okay. Okay, we can see that from here. Okay, okay, this is activity A. Activity A. Okay, there is no predecessor, so maknanya you can have. Okay, maknanya you can start something like this lah. Okay, you can have A, and then B. After that, B also can start concurrently. Now we are using activity on node. Okay, activity on node. And then C also can start concurrently. Okay, A, B, C. After that, D. Okay, D. In order to do D, A and B must complete. A and B. Okay, so you have. Okay, as I mentioned earlier, when there is hanging like this, you need to have a node showing that start. Okay, this is what it shows here. And then we have D. Okay, D require A and B. A and B, so you have D. Okay, so this must go there, and this also there. Okay. So you're going to have D. Okay. So the next one adalah C. C memerlukan E memerlukan C. Okay. You have E. Okay. Prasyarat E adalah C. Okay. Now there is hanging. D and E is hanging, so you need to close. Okay. You have close, and you will get this. Okay. So this is the end. Okay. This is what is shown here in the ebook. Okay, I hope everyone can follow that. Huh? All right. So what happen if we need to do activity on arrow? Okay, activity on arrow. If we want to do activity on arrow, okay, I will erase this, because you have that on your ebooks. Okay, if we use the same table, okay, same table. Let's say now you want to do activity on arrow. Activity on arrow. Okay, so on activity on arrow, we can label the activity. We can label activity. For example, you have activity node 1, go to node 2. Sometimes people do like this. 1 and 2 is showing the beginning and ending, and this is activity A. Okay. Okay. So we can put, we use the notation like this, like this one. 1, 2, 3, 4. So this is just labeling of the node. In this case is activity on arrow. Activity on arrow. Okay. So let's say now we want to do this. We want to have activity A, B, and C. So you're going to have, okay, I would like you to try first before I show. Can you try how to do activity on arrow for the same problem? Okay, for the same problem. Okay, please try now. Okay, what will be the connection? Okay, how it will be connected? Where will be the dummy? Okay, can anyone share with me, or you can show to me on your camera? I want to see. Okay, siapa nak share ni? Can you show on your camera? Okay, let me see this. Okay, ada siapa-siapa nak tunjuk? Okey, kalau macam tu saya nak tanya Okey, Aiman, dah buat dah network. Boleh tunjuk kat kamera tu sekejap. Kenapa banyak hanging tu?
Tapi ada satu tak bersambung. Saya tak tahu.
Yang mana tak bersambung?
Yang A.
Yang A tak bersambung. So dummy connect ke mana tu?
A ke B.
Okey, A ke B. Okey, yang tak bersambung sekarang ni yang mana?
A ke yang last kali punya bulat.
Last kali. So, okay, right? So, yang tak sambungnya, okay, so you have D and E connected at the end, right? Okay, so yang tak sambungnya apa?
Yang A je lah kot. A bersambung.
Okay, ABC tu serentak. Okay, that's correct. Okay, so logically it's correct now. Yang tak sambung. Sebab A dengan B tu ada dummy kan? A, B tu ada dummy, and then that dummy, okay, connected to D. Okay, so it's correct. Okay, semua orang tengok. Okay, thank you, Fahmi. Aiman, right? Okay, thank you. Okay, let me move on. Okay, you masih nampak buku yang saya share ni? Is it you looking at the same screen? Saya lihat sekarang.
Yes, Doctor.
Alright. Okay, the soft problem 3.2. 3.2 dia mengatakan insert a dummy activity and event to correct the following activity on network. What is this? Showing dummy, dummy. Okay, 3, 4, 1, 2. Okay. What is showing here? Okay. In this example, what it shows that you cannot have a connection like this. You cannot have a connection. You cannot have a connection where two nodes, okay, or two activity. They're sharing. This activity is sharing the same start and end. Okay, you see here 1 and 2. This is one activity. Let's say if we say this is A, example, this is A, activity A, this activity B. This is different example than number 1. Let's say this is C, this is D, the F, E, then F. So you see here A and B sharing the same start and end. And end sini end. Okay, kenapa? Why you cannot have a connection? Okay, we know that node in this case, kalau activity on arrow, so this is start, this is ending. So if you have A, kat sini A, activity A, you cannot have the same node, okay, untuk activity B pula. Okay, tak boleh. Okay, tak boleh kita katakan nak letak B kat sini. Kenapa? Okay, anyone volunteer? Why we cannot have like this? Okay, we cannot have two activities starting and ending at the same node. Okay, why?
Maybe sebab nanti nak key calculation tu, kita tak boleh nak tentukan duration mana satu.
Yes, because now we see that duration are different. Even duration per same pun tak boleh. Okay, we need to have, in order to solve this problem, you need to have a dummy. Okay, this is dummy. So maknanya, they can start concurrent. Okay, this activity can start concurrent. A and B. Okay, so in order to show that it is ending, okay, the ending, okay, so we can just connect through a dummy. Okay, so there will be a dummy here. Okay, actually this is not a dummy event. Okay, event di sini bermaksud the finishing lah, finishing. This is a dummy activity which is 0 in terms of duration time, and the rest will follow lah. Okay, the rest will follow. Okay, so that is important of using dummy on activity on arrow. But if we use activity on node, there is no need dummy. Okay, I hope that you can go through this example. Okay, this soft problem. Okay, read on your own. Okay, there are many examples here. Okay, given related to this calculation. Okay, let me show you the slack. Okay, what is the slack? Okay, we have early start, early finish. Okay, late start and late finish, and also we have slack. Okay, what is slack? Anyone knows slack? What is slack? Okay, let me ask someone here. Okay, Azad, what is slack? Azad, you are looking the class through your phone, huh? Okay, Azad. Okay, what is slack? You ikut kelas melalui handphone ya? Tak ada komputer.
Doktor. Ada tapi laptop saya dia tak tahu dia tak boleh connect dengan Webex.
Oh, problem. Albizu jawab kuis tadi pun dalam phone juga.
Kuis saya jawab dekat laptop tapi nak buka Webex kena buka dekat phone.
Oh, okay. Masalah masalah connection Webex .
Saya rasa sebab tu lah.
Dengan komputer tak boleh connect.
Dengan komputer je tak boleh.
Oh, habis kelas lain macam mana?
Kena pakai iPhone juga lah.
Okay. So kecil tu handphone tu.
Tak apa, handphone saya besar sikit. Okay, boleh nampak lah.
Okay, tak apa, jawab soalan saya. Apa itu slack?
Sekejap.
Dah lupa
Slack ni saya rasa saya tak sure doktor Slack tu apa.
Alright, tak apa. Okay, let's go through this again. Okay, let's say we have this network diagram. Okay, we have this network diagram. Okay, so this is activity on node. This is activity on node. Okay, I just use the same diagram. Let's say saya nak pecahkan di sini. Okay, kita belajar bahawa kita boleh pecahkan di sini kepada macam ni kita boleh pecahkan this node. Okay, this node kita pecahkan kepada this will be early start. Okay, let's say this is early start. Berada di sini. Early start maksudnya early finish. Okay, early finish. Okay, duration time. This is for activity A. Activity A. Saya mengambil yang sini saya mengambil yang ni. Okay, activity A. Masa A adalah diberi dalam jadual ni 2 kan? Okay, 2. Okay, so this is late start and then kita ada late finish. Okay, let's say now I want to do this calculation on this diagram. Okay, on this diagram. Okay, so saya pecahkan this diagram. Okay. Okay, boleh saya besarkan sikit kok. Okay, mungkin okay, now looks better. Okay, before that, let me put the sebelum kita tak nampak ni, biar saya masukkan dia dulu. Okay, di sini 2. Okay, daripada jadual ini di sini 3. Oops, sorry. 3 bukan di situ. B adalah 3. B adalah 3. Okay, C adalah 2. Okay. D 4. Okay, D adalah 4. E adalah 4. Okay. F adalah 3. Dan G adalah 5. Okay. Yeah, I hope you can visualize this. Let me besarkan dia. Okay, nampak ya? Azad nampak ya?
Nampak tu.
Okay. Alright. So, sekarang ni assuming network sudah ada. So, sekarang ni kita nak mengira. What we do is, what we call it, forward pass. Okay, apa kita buat dalam forward pass? Azad?
Kita ambil yang paling apa? Kita tengok isikan dia punya earlier start dengan later start.
Okay. So, kalau di sini, kita ada kosong. Dari sini pun kosong, sini kosong. So, jadi sini kita ada kosong. Campur 2 jadi 2 kan? Okay. Sini jadi berapa? Kat sini. Early start untuk C. 2 juga kan?
Dua.
Okay, 2 campur 2 jadi 4. Okay. So, sini jadi berapa?
4.
4. Okay. 4 campur 3. 7 kan? Okay. Okay. For this one, kita ada kosong campur. Ini berapa tadi? 3 kan? Okay, saya pun dah tak nampak dah.
3, Doktor.
Kosong campur 3. And then sini akan jadi. Okay, lupa buat ni. Okay. 3. So, mari sini pun 3. 3 campur 4. Jadi 7. Okay. Di sini 4. Okay. 4. 4 campur 4 jadi 8. Okay. So, sekarang ni berapa untuk G? Early start untuk G.
7.
G dia dihubungi oleh E dengan D kan. So dia mesti menunggu E siap dulu. 7 adalah D siap. Tapi E belum siap. So paling awal G boleh mula adalah apabila E siap. Itu 8. 8 campur 3 adalah 13. So bilakah masa yang paling awal untuk this projek siap? Adalah 13 kan. Okay. Kita ambil yang paling besar. So G tak siap lagi kalau kita gunakan 7. Okay, jadi 13. Alright. So now try to look at the table given here. Okay. G 13. Okay, G dalam table ini ditunjukkan 13. Okay. Dalam table ini ditunjukkan 13. So apa yang maksud dengan table ini adalah early start dengan early finish. So jadi kalau you tengok table ni 0, 2. Okay, we have 0, 2. 0 and 2. And then untuk B, kita ada 0 and 3. 0 and 3. Dan seterusnya, tapi yang terakhir adalah 8 dengan 13. Okay. Kita belum, ya 8 dengan 13 untuk G, yes. Kita dah ada. So now what we need to do adalah we go backward. Okay. Kita panggil backward pass. So in backward pass, kita mengambil masa untuk menentukan, okay, when is the late start. Late start equal to late finish minus the duration. Okay, the duration. Okay, so now we're going to have here, okay, so we have, sebab dia adalah kosong, sebab this just ending node. So 13, 13, semua jadi 13 lah. So di sini pun jadi 13. Sini pun 13. 13 tolak 3 jadi 10. Okay, 13 tolak 8 jadi 13 tolak 5 jadi 8. Okay, balik ke sini dia akan jadi 8. 8 tolak 4 ialah 4. Okay. So balik ke sini adalah 8. 8 tolak 4 adalah 4. Okay. So di sini akan jadi okay, sekarang jadi berapa sini untuk node C? C jadi berapa?
4.
Okay, kita ambil yang minimum. Kita ambil minimum. So sama ada dia 10 ataupun 4. So kita ambil 4. 4 tolak 2 adalah 2. Okay. Sini jadi 2. 2 tolak 2 jadi kosong. Okay. Di sini 4. Balik ke sini pun 4. 4 tolak 3 jadi 1. Alright. So sekarang ni kita dah mempunyai semua masa di mana telah direngkaskan dalam jadual ini. Kita telah direngkaskan dalam jadual ini di mana kita dapat late start dengan late finish. Jadi kalau kita tengok untuk activity A, sama So kita 0 dengan 2. 0 dan 2. Aktiviti untuk B 1 dan 4. 1 dan 4 disenaraikan dalam jadual ini. So dan seterusnya untuk kesemuanya. Jadi kita ada satu kolom di mana slack. Slack ini adalah di mana kita membezakan antara sini pun kosong-kosong. Kita tahu bahawa dalam node ini kita ada early start, late start, early finish, late finish. Kalau kedua-dua masa ini, let me get another highlighter color, different color. Kalau kita mempunyai, kenapa tak keluar? This highlighter is not working. Tak apa. Just use a pen. Maybe get yellow color. Okay, you nampak di sini Kalau these two number are the same, maknanya dia no slack. If early start equal to late start, ni kita kata slack dia 0. Dia tak ada slack, maknanya tak boleh lewat lah. Early start dengan late start sama. So you cannot delay. So is equal to 0. Begitu juga if early finish, sekiranya early finish, late finish minus early finish, kita ada beza. Late finish, late finish equal to early finish. So ini pun menunjukkan there is no slack, slacknya 0. Jadi kalau kita menyemak jadual tadi, di manakah numbernya sama? Mempunyai number yang sama. Early start equal to late start. Early finish equal to late finish. Di node yang mana? Tanesh? Can you respond to my question?
Node A, A, C, E, and G.
So we have A. They are the same, both number are the same. These are also same. And then lagi C. This also the same. And then
E,
E,
G.
G. Right? So
Yes.
this is what we call it critical path. Critical path where there is no slack. Dia tak boleh, maknanya no slack maknanya tak boleh delay. Tak boleh berlaku, tak ada masa tambahan, tak ada masa lebih. So it must go exactly as it is given in the network. So this is slack equal to 0. Slack equal to 0 because both are the same. Early start, late start. Early finish, late finish. So this is also 0. This is also 0. This is also 0. So we call this These are critical path. Critical path. Where is no delay is allowed for all activities on critical path. But activity F, activity B, activity E, there is a slack. Okay, there is a slack. Okay, so now what is slack? Slack equal to the difference between late start minus early start, or or the difference between late finish minus early finish. Okay, Tanesh, I ask you again. Okay, activity F is not critical. This activity F is not critical. What is the slack for activity F?
3, sir.
This activity, right?
Yes, sir. 3.
3? How come 3?
7 minus 4, sir.
No. What is late start for activity? Let's say activity F. Okay, activity F, huh?
Yes, sir. 13 minus 10 is 3.
What? Activity F is
13
not
minus 10 is equals to 3, sir.
No. Where is the late start?
Late start is at 10, sir.
Late start is 10. Okay, early start? Early start is
Early
here,
start is at 4.
at 4. So what is the slack?
6, sir. Sorry, sir. My
6.
mistake.
Okay. Okay, slack 6, meaning that activity F, you can start either at 4 or at 10. Okay, there is no effect for to the completion time. You can delay starting of activity F by 6 days or six. What is the unit time here? I think okay, doesn't matter. It could be days or weeks, depend on the unit time. Okay, if you look at late finish, what is late finish for activity F? This activity. What is the late finish for activity
13.
13? Okay. What is the early finish? 7,
7.
right? So now it's going to be 6, right? So the slack is 6. Okay, you have the slack here is 6. Okay, as I put it on this one. Okay, slack here is 6. Okay, slack here. Is there any slack for B? Yes, right? 4 minus 3 and 1 minus 0. So it's 1. Is there any slack here? Yes, this one slack. Okay, this one on critical path is 0 slack. So this is what is being shown in this table. Okay, so we have that. Okay, activity A, there is no slack. Okay, no slack here. Okay, because it is on critical path. This is also no slack. This one also no slack. No slack. Okay, but activity B and activity D and activity F, okay, which is B, D, and F, they are not on critical path. Okay, they are not on critical path. So we have a critical path with 0 slack. Okay, remember that critical path has 0 slack. Okay, critical path has 0 slack. So okay, let me erase this. Okay, so now you have a critical path which is shown by when there is no when there is no when there is no critical what do you call it, no slack. So okay, as shown here, the start A, C, E, G. Okay, A, C, E, G. Okay, this is the critical path. Okay, whoever being assigned to do this activity, he cannot do any delay. But those who are not in critical path, they can have a delay. How much delay depend on this. For example, this one can delay one unit time. Okay, on someone working on this one. Okay, sorry, someone working on this can delay one. Working on this also one. Okay, on F, he can have a delay for 6 days. Okay, 6 days. So if anyone being assigned A, C, E, and G, he cannot go for holiday. Okay, he has to complete his work first. All right. So any question on that? Any question? Okay, if no question, I'll give you a break for 5 minutes and we come back and I will discuss about variability in project time. Is it okay? Hello, everyone.
Okay, Doctor.
All right.
Okay, Doctor.
Take 5-minute breaks and then I continue with PERT. And
1.3 or 1.28.
1.28. Okay, between 1.28 to 1.29. Okay, if you do interpolation, the value will be between this. Okay, so this is a Z, the value for Z. Okay, the value for Z. Okay, so it will be, which one is closer? Okay, somewhere here in between. Okay, if I'm not mistaken, it will be to 1.282, 2.82 or something like that. Okay, let's say we just okay, we want to get accurate, we have to do interpolation, but if the time is not sufficient, we just assume that, okay, any number between this, any number. Let's say for the sake of simplicity, okay, I will say, okay, because this one is 90, this is okay, it's actually closer to this one. Closer to this one compared to this one. Okay, so let's say 1.28. Okay, so for 90%, okay, my Z will be 1.28. Okay, 1.28. So now back to my original question. Okay, I want to know. Okay, I want to know when the project will be completed. Okay, can you use this number in the Z formula that I just showed to you earlier? Okay, everyone, please try. So using this formula, Z equal to X minus mu divided by sigma. Okay, so in our case, Z will be, X will become the T, which is we want it 16, okay, minus the mu, which was given as 15, and the sigma was 1.7. What was it? 76 or 78? In 76, right? Can anyone confirm to me the value for sigma? Yes, 1.76.
Yes.
Okay. So what will be the T? Which is what we are 90% confident that this project will be completed within, okay, 90% confidence.
17 weeks.
17 weeks, okay? 17.2 something, so 0.3, right? I think.
Yes.
Okay, so we can say that we are confident that this project will be completed, okay, 90% confident, 17.3. If the owner say, no, I want it 100% sure, how many weeks will he complete it? Okay, he say, no, I don't want 90%, I want it 100% sure. Okay, with the will of Allah, okay, I want it 100% sure. Okay, how many days, how many weeks of this project should be completed?
22 weeks.
22 weeks. Okay, so we just get the Z for 3.999, which is very close to 100% coverage of the area. So you get it just now. It was 22 weeks. Okay, 22 weeks. Okay, so you see that 22 weeks. Okay, we can say inshallah 100% finish. Okay, but if you say 15 weeks, okay, as in the original question, we can say I can guarantee you inshallah 50% only, 50-50, okay, the completion time. So now you understand the use of variability in project management, estimation time. Okay, so I hope that is clarify this issue of variability. Yeah. Okay, let me sharing with you again the slide. Okay, stop sharing there. Okay, let me put the PowerPoint. Okay, you see the PowerPoint now, right? Okay. Okay, so we use this formula for variability. So, okay, you now know how to read the tables. Okay, know how to calculate the completion time with a given probability. Okay, so okay, there is also important to know the variability of non-critical. There are times where high variability in non-critical activities may change the critical path. Okay, variability time on activities on non-critical must be considered when finding probability finishing in a specified time. Okay, variation in non-critical activity may cause change in critical path, especially when variability of non-critical activity is very high. You need to calculate the to check whether critical path is changed or not as a result of high variability in non-critical activities. Non-critical activities may have high variability that finally your critical path is changed due to that non-critical activities. So one is you can what? Okay, let me show you example here from your e-books. Okay, you see the e-books now? Hello?
Yes, Doctor, yes.
Okay, so as I said just now, okay, the variability of non-critical activities may change your critical path. Okay, may change your critical path. This might happen. Okay, this might happen. Okay, I show you example here from your e-books. Okay, on chapter 3. Okay, on chapter 3. Okay, 320. Okay, okay, later on you will look into this. Okay, let's say this estimated time. I'm referring to 320, question number 320, estimated time given here for 4 activities and predecessor, and activity estimated time based on optimistic, most likely, and pessimistic. Okay, assume the critical activity are independent. And in the last question here, 3.D, number D, explain why probability that the critical path will be finished in 22 weeks or less is not necessarily the probability that the project will be finished in 22 weeks or less. Okay, so this might happen when the variability or the variance of activity is very high. It may change the critical path. Okay, so we need to check actually the variability, the variance of each of activity, especially when the variance is very high. Okay, it will affect critical path. Okay, if we have example here, okay, let me share with you. Okay, if we see here, okay, the variance, which activity has high variance in this among A, B, C, D, and F? Which one have high variance?
FG.
Okay, activity G is very high, right? Very high variance. So we have to check, okay, whether these are on critical path or not, F and G. Okay, F and G. Okay, so because it may affect the completion time. Okay, in the completion time. So we have to check whether this affect or not. Okay, so in this example, I think it's not mentioned. Where is the critical path? Okay, activity 1.78. Anyway, if we have to check, if it's already on critical path, it's fine. If it's not in critical path, we have to check, okay, non-critical path. Okay, non-critical path, whether this will affect or not, okay, the completion time. Because in our formula, okay, in our formula that for the probability of completion, we have this value of T minus mu, okay, divided of this. So this one, okay, this value, okay, influence this T, which is T equal in this case is, okay, T equal to Z sigma plus mu. Okay, if this T is high, okay, so this value is going to be high also. Okay, so it's not enough just looking at sigma P. Okay, so we also need to look into non-critical. Okay, but in general, okay, sigma P here is used, okay, when there is a normal situation and variability variance of non-critical is not too high. Okay, so that is very important note that you have to be careful in finding the completion time given there is variability. Okay, let me highlight this aspect of the next aspect of project management is related to what we call it project crashing. Okay, project crashing is when there is, okay, this is another aspect. We finish about the project variability. Now another aspect of project management is we call it cost and time trade-off, or we call it project crashing. Okay, why project crashing is important? It is important when we want to reduce the completion time. Okay, to reduce project completion time. Okay, let's say the example just now, it was given as 15 weeks. Okay, suddenly the owner of the project said, no, I don't want 15 weeks, I want it 13 weeks. Okay, so he give you the deadline. Okay, based on our calculation, it was 15 weeks, but he said, no, I don't want 15 weeks, I want 13 weeks. So what you do, this is what we call it project crashing. We have to crash, okay, from 15 weeks to 13 weeks while reducing 2 weeks reduce. How this can be done? Of course, it will increase the cost. Okay, cost will increase. Okay, you want it faster, you have to pay additional cost. So this is leading to the need for us to find the crash cost. Okay, so the crash cost is given by this one. Okay, so where we have crash cost minus normal cost divided by normal time to crash cost. So this is crash cost period. So another way is we call it slope. We got a slope. Okay, so the slope of the cost, okay, crash cost, okay, which is the cost during the crash, okay, minus the cost that you get it from the normal, divided by time, okay, the time which is we call it normal time. Okay, normal time. If I may use t as a time for the normal, minus time for crash. Okay, so this will be the slope. Okay, the slope for the cost per period. Okay, so if we put this in terms of graphic, we will looks like this. Okay, so we have time, we have the cost. Yeah, okay, we have the cost. So this is crash time, which is shorter than normal time, and we have normal cost, which is lower than crash cost. Okay, so this is the slope that we call it the slope. Just not the slope of that. So in order to solve crash cost, we need to find the slope for all the activities. Okay, you need to find the slope for all activities, which is shown here in this example. You have activity, you have the time, normal time, crash time, cost, normal cost, and crash cost. And this is the slope. Okay, this is the slope. Okay, after having all this, okay, we need to identify which slope are on the critical path. We already know which critical path. Okay, A was critical path, C was critical path. Okay, from the earlier information, we know already this critical path. Okay, so if you want to crash only critical activity. Crash only critical activities. Okay, And second rule is priority given to crash. Okay, because we have many option here. A is critical, C critical, E also critical, and F critical, G critical. So we give priority to smallest slope. Because why is the cheapest? Okay, crash cost per week, the cheapest is, in this case, it will be not this one, it's not critical, it will be this one. And the third rule is crash one by one. Okay, meaning only one period at a time. Okay, any question to that, up to that point? Hello, any question? You can ask any question. Is there any question? Respond to chat.
No, doctor. Clear.
All right. Okay, I would like you to go through this, okay, example for you to understand how the crashing can be done. For example, here you have 15. Okay, if you want to reduce it to 14, okay, from 15, we need to crash, become it 14. From 14, we further crash it to 13 if you want it 13 weeks. Okay, must do it one by one. You cannot crash directly from 15 to 13. Cannot. Okay, why? Because every time you crash, the costs are different. Okay, because we have different slope. Okay, every time you crash, you might change the critical path. Okay, because this unit of crashing is per week, per one duration period, one period, at one period. So when you crash, after you crash, and let's say you have selected just now in the example of this, the cheapest one is A. A, the normal time is 2, crash time is 1, meaning that you can crash only 1 week. Activity A can be done using 1 week at the cost of 22,750. But if you use it 2 weeks, the cost is $22,000. Okay, additional $750 if you make it shorter 1 week. Okay, so what is the cost of this project? Is summation of all these costs. Okay, summation of this cost is the cost for the project. So, but if you crash it 1 week, the cost will additional, okay, of whatever you have that, you have to add 750 additional cost. Okay, after you crash that from 15 become 14, you have to recalculate the critical path again. So this one, if you crash A will become 1 here. Okay, the rest is the same. So you need to calculate again. And this one will become, most likely become 14 lah. Okay, so dia become, di sini akan jadi 1, di sini akan jadi 1. Okay, kena redo the whole critical path calculation until you get here is 14. Okay, here is 14. Here I think is, okay, still, so it's become 12. Something like that, okay? So you have to check the whole network with a new critical path, and after that, check again when is the smallest slope, and then you crash that again, and then redo the critical path. Right, so I think that's all. I think time is up now. Thank you very much for your attention and participation in this class. Okay, remember next class, at the beginning of next class, we give you a quiz on quality. Okay, so the class will we'll start at 12, we finish at 1 because I have another activity, official activity in the school, okay, on that day. Okay, is it okay? We start at 12?